Okay, my apologies, everybody. The rest of you may have been on time. For some reason, I was thinking we had another 10 minutes, so just finishing up my lunch. But again, we would have started this at 1:15 Eastern, 11:15 Mountain. And so welcome back to the second part of today's session, where we're going to actually be diving right into this question about, generally speaking, how to define flash drought. So we're going to start, rather than at that level, backing up a little bit and talking about what makes flash drought different than other droughts, if it does. I know there's been a lot of active sharing in the chat box, but then also what are characteristics of flash drought? And then with that, what does that tell us about how we might be defining it? To start this part of the program, we're going to start with Joel Lisenby's presentation on the flash drought literature review, which I think you all had received a copy of. So Joel, we'll dive right into that and then take questions after that.
Thank you, and hello everyone. My name is Joel Lisenby. I am a climatologist and a drought information coordinator at NIDIS, and I will be walking you through a literature review that NIDIS put together for this workshop. This should be a review for most of you who read the written report. Also, as a note, this presentation is best viewed in full screen mode if you have that capacity. To start out, the first mention of flash drought in my literature search. In August 1999, R. Shostak authored a piece for EOS Transactions magazine in which prominent physical scientists were interviewed about drought. Shostak points to the slow onset of drought compared to the more dramatic and sudden weather events and states highlighted here. Droughts receive less attention because they are slow-moving disasters. There is no such thing as a flash drought, for instance. It was only 3.5 years later that the term flash drought began showing up in the published literature. The first mention of the term chronologically showed up in Peters et al., January 2002, a paper on the derivation and utility of the Standardized Vegetation Index, SVI. The term showed up again in Svoboda et al. 2002 paper on the US Drought Monitor. I would like to note here that Mark Svoboda was a co-author on the Peters paper, so there is a link there. The Peters paper has been referenced twice in relation to the use of the term flash drought. First by Twidwell et al. 2014 in the Journal of Applied Vegetation Sciences, a paper about drought-induced woody plant mortality. And then again by Lee et al. In their 2015 paper in Aeolian Research titled Cause of Wind Erosion in the Dust Bowl. And that's looking at the southern Great Plains of the North America during the 1930s, in which they claim the Dust Bowl may have initiated as what is now called a flash drought, referencing Peters et al. 2002, that persisted and intensified. The Svoboda paper has been referenced much more, with special attention to these 4 papers, which will be referenced in more detail shortly. The Svoboda paper gave a general description of flash drought, shown here on the left. It mentions a heat wave and short-term dryness that leads to a rapid onset of drought with impacts. The 4 subsequent references from the Svoboda paper each describe flash drought just a little differently. One paper describes it as a short-term drought, while 3 describe it as a rapid onset drought. One of these papers was a literature review by Otkin et al. 2018. In this paper, Otkin took a hard line that flash drought should be distinguished from other drought by its unusually rapid rate of intensification. This paper has been referenced many times, not always by papers describing flash drought as a rapid onset event. Sine et al. 2008, colored green here, is unique among the flash drought references. This was given as a talk at the 22nd Conference on Hydrology on 20th of January 2008 in New Orleans. They said, and I quote, "Flash drought is considered to be a short-term yet severe event characterized by moisture deficits and abnormally high temperatures," close quote. I would usually not consider this to be a key reference, but Sine et al. Was subsequently referenced by Hunt et al. 2009 and Mosny et al. 2012, which was then referenced by Otkin et al. 2013. In total, 16 papers provided a general description of flash drought. Many of these described flash drought as either a rapid onset drought or a drought that began as a rapid reduction in rainfall or soil moisture. It's up to discussion how these are practically different, but I thought it was worth noting that not all flash drought descriptions jumped straight to the word drought. These are all the flash drought general descriptions that considered flash drought to be a rapid onset event. A minority of general flash drought descriptions considered flash drought to be a short-lived but intense drought event. These were Sine et al. 2008, which I've already mentioned, Hunt et al. 2014, and Zhang et al. 2020. Here I'm showing all references that provide a general description of flash drought. Thin arrows indicate a direct reference that connects the papers, and non-arrowed lines indicate a topical connection. The 2012 drought event caused a spike in flash drought research. Some of these used a new definition or description, but most relied on existing definitions. 11 papers in our review define flash drought by its rate of onset or intensification that are tied to specific thresholds or various indicators. The first of these was Anderson et al. 2013. For sake of time, I will assume that these definitions have been read before today's workshop. And also, before today's workshop, I asked you to provide your professional opinions of these definitions. And I received feedback from many of you, and I will be touching on some of your comments as I go along. For Anderson et al., the pros of this definition that you mentioned are that it uses variables that represent the physical impacts of drought. In this case, it's ET and soil moisture. By standardizing the anomalies, this allows you to account for seasonal differences. However, one of the cons that was mentioned, in fact, the only con that was mentioned here, is that changes of greater than 1.5 standard deviation over a 4-week period are too steep. Ford and Lavoisier 2017 was adopted by 3 subsequent papers. They defined flash drought as when the soil moisture percentile at a station declines from at or above the 40th percentile to at or below the 20th percentile in 4 pentads or less. You said this definition was easy to understand, and it uses variables that represent the physical impacts of drought. However, it also uses changes in soil moisture to define flash drought, and it does not distinguish different intensities of flash drought. This method can be limiting because the use of percentiles convert a nonlinear distribution to a linear distribution. Park et al. 2018 used 3 satellite-derived indices to define a flash drought. They were heavily reliant on remote-sensed data. You said these indices are not commonly used and are difficult to understand, and the definition does not consider changes with time, which is a defining feature of flash drought according to this commenter, and it has a threshold that is too high. It does not require the dry periods to last more than 1 period, so it's too short. Christian et al. 2019 based their criteria on the principles outlined in Otkin et al. 2018. They used a standardized evaporative stress ratio, and about their definition, you said, this approach is scientifically sound and comprehensive. It uses a variable that represents the physical impact of drought, in this case it's evapotranspiration, and a 30-day period is good for representing flash drought. However, on the other hand of this, evapotranspiration and potential evapotranspiration data are not available everywhere, and you'll need to fill in some gaps with either reanalysis data or satellite data. And this definition does not require that drought conditions persist for some period of time beyond the rapid intensification period. Noguera et al. 2020 used 3 examinations of the SPEI, and for this definition, you said this definition includes both drivers, the SPI, and impacts, evapotranspiration. However, it also does not require that drought conditions persist beyond the rapid intensification period. 4 definitions were based on, they based the concept of flash drought on the US Drought Monitor, each with their own pros and cons, which I won't go into in detail, but in general, mostly the comments received on these centered around the ease of access of the data as a pro, and the operational nature of the US Drought Monitor, also a pro. However, there were questions about the period of time that should be considered to define a flash drought. Of the 4 papers listed here, each used different periods to define a flash drought. One of these U.S. drought monitor definitions came from the Pendergrass et al. 2020 paper, which also provided a second definition based on the Evaporative Demand Drought Index. This paper and these two proposed definitions were developed by the attendees of the Aspen Global Change Institute workshop, so AGCI, Aspen Global Change Institute workshop, that took place in September 2018. There were a lot of comments on this particular definition, which I do not have time to go into. Instead, I'm going to jump straight to an analysis that was done by Mike Hobbins, who's attending today. On the left is a count of flash drought events based on the U.S. Drought Monitor definition, which is a 2-category increase over 2 weeks and sustained for a further 2 weeks. On the right is a count of flash drought events based on the Eddy definition, which is a 50% increase over 2 weeks, sustained for a further 2 weeks. These are plotted using the same scale and counted over the same period. The takeaway here is that the two definitions proposed at the AGCI workshop and published in the Pendergrass et al. 2020 paper capture different events altogether. Here, the orange circles represent flash drought definitions that consider flash drought to be a short-lived but intense drought event. Most of these papers also acknowledged rapid onset of drought as a key characteristic. The first of these was Hunt et al. 2009. In fact, this was the first paper to use measurable criteria to identify flash drought at all. But notwithstanding that, the most referenced of these was Moe and Lettenmeyer 2015 and 2016. Moe and Lettenmeyer provide two flash drought definitions. One is a heat wave flash drought, and the other is a precipitation deficit flash drought. Both of these require a flash drought to include a heat wave, which by nature of the phenomena does not persist for more than a few weeks. 6 papers began from the Moe and Lettenmeyer definitions and then made some adaptations in their own definitions. Of these, of the thoughts submitted on about this type of flash drought definition, there were only criticisms, including these. 1, the method identified events that are too short to be a drought. Next, the soil moisture threshold of 40% is too high. A positive evapotranspiration anomaly does not necessarily mean drought stress on plants. The precipitation and evapotranspiration thresholds are too modest to ensure that meaningful impacts are occurring. And as a final note, it was pointed out that the drawbacks mentioned for the Moe and Lettenmeyer paper were also applied to all of the related definitions. There were 4 papers that considered short-term drought events and are a little different from the others. Jan et al. 2018 described flash drought to be a, quote, a type of drought that has a rapid onset and short duration from a few days to 1 to 2 months, close quote. They referenced Moe and Lettenmeyer in their lit review paragraph, but not in their formulation of flash drought criteria. Their method, however, was very similar to Moe and Lettenmeyer, and your comments about this definition pointed to the same underlying issues that came up from Moe and Lettenmeyer. The second paper, not directly linked to Moe and Lettenmeyer, is Zhang et al. 2019. In this paper, a flash drought event is defined when the monthly July or August rainfall is less than 100 millimeters. Your comments on this definition point to the lack of impacts and the inability for this to be applied beyond one specific climate region. While not using the term flash drought, Lee et al. 2020 referenced other flash drought papers to define what they called a short-term drought, lasting a few weeks or even days, using a standardized antecedent precipitation evapotranspiration index, or the SAPEI. Your comments are that this method does not look at how conditions are changing, which means that there is no guarantee that it is identifying an actual flash drought. Finally, the Lee et al. 2020 paper required that a flash drought be both a rapid onset and a short duration event, and they used measurable criteria for both. You are critical that this is a region-based metric, which is complicated because by this definition, the flash drought area is allowed to move from one pentad to the next. This literature review also looked at the indices. It looked at which indices were used in defining flash drought. Soil moisture, evapotranspiration, temperature, and precipitation were used the most. I've highlighted here the drought monitor as it represents a combination of several indices. But to be fair, the ESR, EDI, and SPEI are also combined indices. So when pulling these base elements from these indices and combining them with the counts of other indices, evapotranspiration becomes the most used indicator of flash drought, showing up in 11 papers. Finally, we looked at which papers used multiple indices as an indicator of flash drought. I've highlighted these according to the papers that used the drought monitor in red, papers that used one indicator but in multiple ways in yellow, and then everything else. On that last point, an example of this would be combining the total soil moisture with the rate of change of soil moisture to come up with a drought index. So just to conclude, flash drought is a relatively new research term, and research on this topic started out fairly slow in 2002, but it has really increased since the 2012 drought. The literature contains a divide between defining flash drought as a rapid onset event or requiring a heat wave, which, by nature of the definition, means a flash drought is a short and intense event. It does not persist. And finally, only people who preferred rapid onset definitions responded to my request for feedback. So I suspect I have a bit of bias in the results that I showed. While that concludes the literature review, I would like to point out that we composed this review in August, and we included all of the papers published up to 31st of July this year. A few of you subsequently pointed me to research on the topic that had been published between then and now. A quick search showed 8 new papers, although there may be more. This includes research by some of you who are at today's meeting, which you're welcome to bring up in today's discussion sessions.
Okay, great. Thanks very much, Joel. And I'm sure you all found that a really fascinating presentation, although of course pretty fast, a lot there. We are trying to stay a little bit on time, and again, I apologize for a late start this afternoon. But are there any questions for Joel specific to clarifying the analysis? To get into the actual substance of the questions about definitions, we're going to do that in the breakouts. So anybody have any questions specifically about the analysis? Okay, Peter, go ahead.
Yeah, my question was Joel, when you broke out the different variables used to define flash drought, you said evapotranspiration was the number 1. Was that both potential and actual ET or just actual?
Great question, Peter. That was both. I rolled them both into one. It could have been done either way. At the time that I was counting them all up, it just seemed like a simple approach to take.
Thanks.
Any other questions? I know there was a question about whether the presentations will be available, and yes, they will. So no need to worry about that. You'll have a chance to listen winter nights to Joel's presentation. Okay, well, with that, thank you very much, Joel. It was a lot of hard work, and we're really proud of the fact that within our little NIDIS team, we've got more than one more meteorologist, climatologist, so kind of gives us some chops in this domain. But we're going to move on now to the breakouts. And so, Brian, if you can bring up that slide. All right, so again, this is the first of 3 breakouts here for the workshop, where in a smaller group, you'll have a chance to thrash around a little bit more about some of the topics we're bringing up. And just want to add, though, thank you all for your comments in the chat box. It really is very rich. And again, we will be saving that and making that available at the end as well. So for this first breakout, we're going to explore flash drought characteristics. We'll have about 45 minutes for the discussion, and you have been assigned to a group based on the input you gave at the beginning of the registering for the conference. So reference the list in the agenda to find your group, and then you can use Google Meet, the link provided either on the agenda, farther up at the top of the agenda for this part of the period, or in your calendar invite. And Molly's also put the links by group into the chat box. So again, we'll leave this plenary open, but at this point you can all go and click on that link for the Google Meet and enjoy your breakout. Let me just say really quickly, I want to thank our fellow NIDIS staff, our advisory group, and also folks from NDMC for helping us facilitate and monitor these breakouts. So again, we'll see you all back here in about 45 minutes. Okay, everybody, welcome back. We're going to actually try to start this next section on time. And we did have just this little brief break between the breakouts and now the plenary for our facilitators and moderators to organize their slides. And so they're coming in as they are prepared. So we'll be a little bit out of order, but we do want to march through these and give each group a chance, particularly the facilitator will be speaking for the group, to share their thoughts on the topic of the breakout sessions. I must say that I was sort of dropping into each of the breakouts for a little while and seemed like you all were having very active conversations. In some cases, even a couple arguments were heard, but that's great. That's exactly what we want to do. This is intended to be a good exchange of ideas. So group 5, I believe that's Amanda, if you want to start.
Yeah, I can go ahead and try to keep this brief so we keep going. So our group, when we talked through the questions, each of the questions led into themselves very easily. And the first one with the key characteristics of flash drought, the group landed on evaporative stress broadly as what is the key characteristic, with distinctions by season and region being very important. And that continued to be the theme throughout most of the discussions, how important that regionality, that seasonality is for this. To talk about a little bit about the onset versus duration from a communications perspective, especially some of those that are more working closer with the users, they thought flash needs to be used similarly as other uses have used it. But for that group, for our group, it definitely meant onset, but not necessarily duration, but also simplification of our definitions. But also some clarity is needed for what our goals are here and for the definition in general about audience, which is academic versus those in application. And then linking here to impacts, questions came up with some of the key characteristics and importance was how we define flash drought when it's within a longer term drought versus the start of a drought, and health came up, for example, but that really is linked to our impacts and the key characteristics of flash drought. Next slide. And then our indicators really fit in with what are those key characteristics. So they latched onto what indicators really are related to evaporative stress, EDI, ESI, with different weights potentially of them and other indicators depending on season and location differences. And then impacts themselves are an indicator. And so we know how hard it is to quantify, as we said before, in seasonal and regional differences, and can have a huge, but they can really ramp up very quickly and themselves are almost one of the first indicators for flash drought. So they brought that up. And I think that's it.
Thank you very much. I know the slides are coming in a little bit out of order. Let's just carry on with group 6 next.
We have the slides for group 6. That was my group. We were the awesome group. We did have slides.
Just going to say, and again, people, apologies for the little bit of a hiccup on the on sharing the slides. We had that 15-minute window, which is pretty tight, to turn around and get your slides to run.
All right.
Go ahead.
So starting out with how it's different from how this drought is different from normal drought. I probably won't talk too much about this, as this was really just to wet the whistle for the next slide. So Brian, can you go to the next slide for me? So some of the key characteristics of flash drought. Within my group, we had a little chat about the rapid onset versus rate, the duration. And within my group, nobody really thought that a short duration was the defining feature or a characteristic of a flash drought. You could have a flash drought whether it's short or very long, but we look specifically at the rate of intensification, although that's not necessarily the onset. You could have a rapid rate of intensification right at the beginning of the drought, so it onsets very rapidly, or you could have that happen later on. I have a few sub-points about each of these, though I don't think I'll have time to go through all of them. I'm trying to think if there's any really important ones. Oh yeah, so the question was, one of the questions was rapid intensification of what? And we thought maybe the rapid intensification of available water in the landscape, wherever that might be, whether it's soil moisture or available water for plants or precipitation, all of that could be included there. Also, within group 6, we thought that it's really important to look at the impacts. And that is also where this short duration versus long duration debate comes into view, because you could potentially have some severe agriculture impacts from a very short drought that hit a very sensitive time in the growing cycle, or you could have impacts that last a long time that might impact other parts of the economy. Although it was pointed out that if you have either a rapid onset or a rapid intensification or just a very short drought, regardless, it seems that agriculture and the plants, like native plants, those seem to be impacted first, and so those get hit first by a flash drought. So the impacts on plant life is one of those. Next slide, please. Some of the key indicators. So where we started from defining a flash drought as a rapid intensification of this drought period, we thought that the rate of change has to be fast relative to climatological normal rate of change for this list of things. So if you have a rapid rate of change in your soil moisture or in evapotranspiration, etc., then that's really how you would characterize that. So it's not just these elements, but it's the change in those elements. And that's it for my group.
Great, thanks, Joel. Okay, and as you guys can see, we're taking a little time to get the slides loaded up, but we're going to do group 7 next. Molly's ready to go.
Ready, except for unmuting myself. I will go ahead and maybe just get started as we're waiting for the slides to come up. Let me open mine up really quick so I can reference that. Ah, there we go. So our group has talked about some of the things that have come up in the previous 2 groups. In terms of the key characteristics, I think the rapid intensification was the most prominent characteristic, and we did talk about duration as well, but really had feelings on it can be short or it could persist for a while, for example, like in New England this summer. One of the conversations we briefly had, but didn't really dive into too much, but I think it's important to note, is do flash droughts only occur in areas where there is no drought, or can drought be present and it just and then it becomes a flash drought because of the rapid intensification? So trying to decide, we didn't really come to a conclusion on that. One of the other big takeaways is it's a growing season issue because ag takes the biggest hit. However, we do need to think probably beyond agriculture in the growing season. For instance, if small streams are impacted, that can impact the ecology, and also the impacts can be felt year-round, even if the flash drought does happen in the growing season. The other important note is that specifically in New England and other areas in Missouri, for instance, fire danger ramped up much more quickly compared to other droughts. Next slide. And in terms of what indicators should be used, in general, we mentioned that the ones that were in the literature review, ET, potential evapotranspiration, precip, temperature, and soil moisture where it's available are important indicators. We did want to note that the mesonet data is helpful. For instance, if it measures solar radiation or vapor pressure deficit, some of those more unusual patterns could come out by having some of that data. And then also it's important to consider soil type and characteristics too, especially just having that local knowledge of knowing where places could go down quickly, downhill quickly in flash drought. That's our summary.
Great, thanks very much, Molly. Okay, again, a little bit out of order, but we'd like to have group 4, which Andy, I believe that's your group. If you could turn on your camera and then we'll slide. If you want to do as Molly did, just start sharing some stuff, feel free.
Sure. So you can hear me, right?
Yes.
Good. All right, so I'll start sharing some stuff and the slides will come up shortly. So really what we want to remind the audience here is that flash droughts are a class of droughts that are characteristic to regions. And somehow We had a little bit of discussion around this and how it might get lost in the fray where flash droughts may just be overemphasized. They're a class of drought. We really focused on onset, the rapid onset here. And we didn't focus so much on duration because of our impacts focus. So once you're in a drought and that drought is persisting, the decisions and actions don't necessarily change, but decisions and actions in response are really important during that onset phase when the drought is coming on and the impacts are being felt. So from an impact community, that rapid onset was most key. So in terms of considerations here, because drought itself and flash drought being a class of drought, we include seasonality and regionality as those important aspects. Because with seasonality, the impacts are different in a given region, say from winter to spring or summer. And you can use the Northern Plains as an example, or even the Midwest United States, because the impacts are most felt during spring and summer just because of relevant sectors. And also in terms of regionality too, that's an important consideration. And we sort of batted around two really different regions and different examples. The Pacific Islands, for instance, very different, say, from the Midwest United States. And you can even use examples within the CONUS, Northeast from the Northwest or even the Midwest. So moving on to the next slide. We focused on indicators that are integrative. So they include many different individual variables and these integrative indicators that are relevant to sectors. And we focused on the leading sectors here because we're interested in quick onset drought and the impacts related to it. So we wanted to focus on leading sectors. And agriculture is a leading sector, whereas hydrological drought, hydrology, river flows, wells, they're a lagging sector. So we chose to focus on the leading sectors. In terms of integrative indicators relevant to those leading sectors, we threw out soil moisture, evapotranspiration, vegetation health, eddy, conditions of pasture and rangeland and forest, and threatened crop yield. So all of these indicators, they include relevant variables that we predict in the prediction community, like precipitation and temperature, but they include all those relevant variables. So I want to thank Group 4. I think they did a great job, and thank you for the discussion.
Great, thanks, Andy. Okay, now we're going to turn to Group 1. So Jason, that is your group. I invite you to turn on your camera and again, maybe start extemporizing while we wait for the slide.
All right, so we were Group 1. Want to thank everybody. We had a really lively and engaging discussion, so that was really good. Really good to be part of. So we reached a lot of the same conclusions that the other groups have reached. For one thing, we definitely. I'm just gonna go to my slide 3 here so I can see what we wrote down. So there definitely was some confusion regarding what the definition for flash drought should be. So that of course then impacts what kind of characteristics people view as as a defining feature of flash drought. We did agree, though, for the most part, that it should be portrayed. A key characteristic is a rapid intensification. Whether that means it's rapid onset or rapid intensification during existing drought, that's yet to be decided. But we definitely did agree that there should be rapid intensification. We also, as a couple previous people have said, we think it's important to not necessarily look at flash drought as being a distinct type or distinct feature, but instead it blends into other types of drought. Like if you look at agricultural drought, when does it transition into hydrological drought? If it lasts a long time. I don't know if there really is, a set break point. And the same thing applies with flash drought. You might have a period of rapid intensification, and then just kind of seamlessly transitions into a longer term drought. Other key characteristics are that you generally get high or enhanced evaporative demand. High winds were brought up in some locations, high temperatures, below normal precipitation. There's also a decrease in soil moisture, and we also put a lot of emphasis on impacts. So that could be vegetation impacts, it could be soil moisture impacts. So that's a very key characteristic of all types of drought. So of course, this should also be important for flash drought. Next slide, please. And then for indicators, basically it can all be summarized with the last bullet point, where we agreed that we need to look at a set of indicators, and this is necessary because because flash droughts are characterized by compound and cascading impacts. That basically means that no one data set can capture all of the characteristics of flash drought. So kind of echoing then what Andy was saying, we were thinking then that things like soil moisture and evaporative stress, it's like the evaporative stress index and its various variants that can capture either vegetation stress or moisture deficits are very important. We can also use the U.S. Drought Monitor, evaporative demand indices such as EDDI. But again, just to reiterate, the most important thing is that you have to have a large set of indicators. So that was it.
Great, thank you very much. Okay, now we're going to move to group 2. Mike Hobbins, that's your group.
Do you have my slides? Or I can just brief.
It will just take a moment for them to come up.
Okay.
Again, we didn't quite plan enough time for our AV team to get things integrated.
I don't know if you can see me or if you want to.
Here we
So-
go. Slides.
Okay, let me. There we go. So we talked about how the timing of flash droughts are distinct from normal droughts. It's how, to a great degree, the timing of the flash droughts dictates their effects. Clearly, they're less predictable than normal droughts, which is particularly relevant when you think about how long it takes to make a decision. We guessed that in regions that don't see a lot of flash droughts, that there would be complacency with regard to them. And we threw out the current New England drought as an example, but that really sort of beat that, where it's in a region where they don't see a lot of flash droughts, but they picked up on it pretty early. Another characteristic was the spatial extent, whereby flash droughts generally start smaller than normal droughts, at least at first. At least the onset the flash onset is a small area. We raised the issue about some species not being resilient to short-term shocks, as opposed to long-term development of a dry surface. Short-term shocks are particularly important to some species in ag. And we raised the question whether recovery is different after a flash drought. I guess it's a human impact of flash drought. The sort of recovery dollars that they're missing, maybe because the drought flashed and it left, and we didn't see it in the decision-making monitors. Next slide, please. So the key characteristics: extreme heat was an obvious one. That it's more important of these short time scales than the normal drought. It's very important how it times with precip deficits. We came to the conclusion that rapid onset is much more important than duration, which gets back to those questions we were raising in the very first in the morning. Elevated ET is certainly key in areas that start wet. In areas that start dry, ET won't elevate; it'll decline, whereas the rapid demand will increase. The duration, of course, is another key question. We can't evaluate the duration until the flash drought is over. We were tossing around the question of duration and onset again, yes, onset. And we came to the conclusion that rapid onset droughts are important in and of themselves. If they're not going to be defined as flash droughts, they still need to be studied. We asked the question: can you have flash droughts without impacts? Because early warning needs to precede those impacts. So early warning needs to be predicated on indicators as opposed to impacts, obviously. And we talked about ecological flash droughts. Are our current metrics able to capture ecological impacts? Perhaps they're not relevant to those sorts of flash droughts. And we asked the question: where do flash droughts have to start and finish? Is it D0, for example? Next slide, please. So indicators. We didn't go so much list a bunch of indicators. We talked about them in sort of general context. there's a regionality to them. In the Western US, we're interested in fire weather and fuel moistures that they must be captured. Whereas in the Eastern US, it may be easier to look at evapotranspiration and vegetation stress, because they may be seen first. And not only east-west, but also irrigated versus non-irrigated. And that raises an issue of, what's the word? Water rights in the Western US. Senior water rights may not experience flash drought because they're able to irrigate, whereas junior water rights people may suffer. So the US Drought Monitor, people use that as a benchmark of flash droughts, and it's designed as a planning tool. It's not driven by losses. We considered it not to be a good indicator of flash droughts for a few reasons. By its very nature, it's sort of a large tanker to steer. It takes a lot of inputs, and it should have a lot of momentum behind it. Therefore, it might miss flash droughts by its design. Flash droughts with extreme impacts are often not reflected in the drought monitor, which is the same thing. This has really important economic implications for relief. And the US drought monitor is only 20 years long. And this brings us to another point, which is on the next slide, talking about periods of record is really important. When we look at flash droughts, we're looking at droughts already, which is the extreme of the distribution. But in flash droughts, we're looking at the fastest of those extremes. So we're looking at the extremes of the extremes. So we can't just have a 20-year record or a 40-year record. We need the longest possible record we can have. So that precludes things like the US Drought Monitor as a strict benchmark or the only benchmark. But it does also tells us we need to look at variables that have long periods of record. Of course, that brings us back to precip and temperature. But we are using reanalyses. Some of the reanalyses now are 70 years long. Some are even longer. So the periods of record are absolutely key. We can do retrospective forecasts using an NLDAS for soil moisture. We mentioned, we talked about predicting flash droughts using NLDAS land surface models at the 1 to 4 week level window. But for predictability, it's key that your variables are predictive, but that might bias us in terms of our monitoring systems towards precip and temperature, and therefore miss the effects of wind, solar radiation, humidity, for example. We estimated that a 2 to 3 week forecast would be a sweet spot for stakeholders. And obviously predicting flash droughts, amelioration or intensification is useful for decision making that's proactive. And I think that's all we have.
Great. Thank you very much, Mike. Boy, a lot in there, and again, a lot throughout the presentations, the report outs. So we're going to now move to, let's see, Group 8, I believe, and that would be Viva.
Hi. Again, I want to just say thanks to my group. We also had a pretty lively discussion. I am not going to restate almost all of the points that have already been made were points of discussion within our group. And so, we're going to hit the high points here and I might make a couple of redundant statements. Again, for the group that I worked with, rapid onset, rapid intensification go hand in glove with regards to key characteristics of flash drought. On the topic of rapid onset, as was said by many rapporteurs before me, monitoring forecasts are critical. The key to flash drought is going to be seeing quickly or discerning very quickly that this drought is forming very rapidly. So the rapid onset piece was identified as a key critical part of this entire discussion around characteristics. And then also the rapid intensification, which gets back to the point about the importance of impacts, because in a situation like a flash drought, impacts are going to start to be seen very rapidly, and because things are moving so rapidly, they're starting to cascade and compound. And so the ability to respond to a flash drought event makes it even more of a challenge. So it's not just about, when you're talking about rapid intensification, which is a lot of what the papers looked at that Joel presented on, we need to look not just at the category increases, but also at the way that the impacts themselves are increasing and building upon each other. Short duration was something that was discussed and thought to be important as part of this conversation, but there was a certain element of we need to define what that duration period is. What are we going to define as short? And will we see it fast? Will the characteristic of short duration, will we see it, or will it really be something that when we look back at the event, then we will see, oh, this event only lasted for this long, therefore it has met the criteria as a short duration event, and that makes it one of the characteristics of flash drought. So there was some good discussion, but still some questions about how short duration would play into the overall definition of flash drought. We also looked at seasonality as an important factor. By region was an important issue, and then obviously sector, a lot of conversation around the ag sector, but also about the water utility and the water management sector. And I'm not going to repeat some of the excellent points. And my colleagues ahead of me were more eloquent in some of these areas, so I'm not going to repeat them. Next slide. We focused on the indicators and sets of indicators, a lot of the same discussion. I'm not going to read directly from this slide because we captured some of the direct quotes that some of our team members made, but I will say that things like evapotranspiration, soil moisture, vapor pressure deficit were all identified as very important indicators. In addition to not just identifying the right indicators for flash drought, there was quite a bit of discussion about the importance of developing the thresholds. So what will be used as the baseline set of conditions that will, when we start to deviate from that baseline set of conditions, that will be the indicator that we're moving into a flash drought. And then what will be those thresholds for ET and for soil moisture and vapor pressure deficit that will give us an indication that this is a flash drought that we are seeing starting to shape up. There were a couple of good comments made about the U.S. Drought Monitor. I raised the issue about whether or not, and I think Mike Hobbins talked about this very well, about whether or not the U.S. Drought Monitor is the right tool for a flash drought, given the fact that the rapid onset nature of this event is really the most critical characteristic of flash drought, and the U.S. Drought Monitor doesn't really respond that quickly to meet to kind of help with that rapid onset determination. It also looks at a suite, depending on a lot of different things. It could be looking at as many as 50 indicators of these more traditional droughts, and whether or not there is an opportunity here to really hone in on a smaller group or smaller suite of indicators that are coming out on a daily basis that would be better suited to kind of a more of a rapid or a flash drought tool that would help with decision making. We had somebody from the state of Iowa represented in our group, and for that individual and his team, looking at seeing impacts as they're shaping up, being able to be nimble and agile and to be able to move quickly is going to be very important. And so whether or not the U.S. Drought Monitor fits that need, I think was a lot of discussion. There was also some discussion about whether or not it was even prudent to have a one-size-fits-all, whether or not the U.S. Drought Monitor should be the one drought composite drought tool or drought indicator that we should be looking at for flash droughts. I'll leave it there and just say that Mutu, who was in our group from CPC, shared some research that he and his team are going to be embarking on, hopefully here real soon, that will address some of these other issues that were raised today, I think. Also, he raised the issue of maybe having a better understanding of where the history tells us are highly vulnerable areas of the country to flash drought, historical flash drought events that even the U.S. Drought Monitor, we don't have records of because the Drought Monitor only gets us out to 20 years in the past. But if we could start identifying more vulnerable parts of the country, that would also help us to hone in on focusing indicators on those parts of the country that have historically shown to be more vulnerable to flash drought events. And I'll stop there.
Great, thank you very much, Viva. Really appreciate that. Okay, we've got one more report out. Mark Svoboda, did you want to go ahead and share your camera? And Eva, you're welcome to turn yours off, or you can stay with us. And Mark, I understand you guys don't quite have your slides. You just had more talking to do than there was time for. So yeah, you're gonna extemporaneous, or I guess go off your own notes.
Yeah, and then I'll populate your template for the official record later. But for sake of time, let me just, and you can hear me okay, right, Marina?
Yep, you sound great.
Okay, just jumping in here on the questions from group 3. Let's jump in on rapid onset versus short duration. So one of the members of our group was really interested in the predictability side of it. So having a definition there is pretty critical for aspects of predictability. And I think that was a good perspective to bring into the group, not just from the monitoring side, but also from the predictability side as well as the forecasting, as those are all slightly different needs, right? And the other thing that came up, again, I'm just going to kind of cherry pick that doesn't overlap and duplicate what we've heard a lot of consistency on some of these issues between the groups, at least on the rapid intensification seemed to be favored more than the duration aspect of it, although not totally. But I think the key theme that came back there that was made a couple times by a couple of the members is the consideration of flash drought as being a subset of drought. So again, focusing on that onset period. So when you bring duration into that definition at the time when you're monitoring it, and certainly if you're forecasting it, you may not have any clue as to how long that drought will last. So whether that's going to be a short or long-term drought, as Viva just said, I think you can look back on that retrospectively, but at the time, hard to say. So that muddies the waters quite a bit too. But because of that, I think the comment was made here that duration perhaps is not as critical as rapid onset is. Not that it should not be considered, right, or be included. Otherwise, you can have a case where I think when you do have a short duration assigned to it, where you could have multiple or several flash droughts occurring in a given season, certainly in a given year, maybe even a given month. So that's one aspect that could be very confusing to the public if you're crying wolf every 2 pentads or something like that. So something to consider. On the question of if there's a difference on the impacts between flash and conventional droughts, I think this was brought up earlier too, that, you know, ag seems to be the one out there on the picket line for first impacted. But at least our group also discussed in a little detail the ecological side of drought and how those will manifest themselves. And, you know, maybe we're not doing as good a job of monitoring on the ecological side. And certainly nationally, it's been a very long and hard road to collect impacts, for example, in associating with various types of drought. Timing was another big one here. As it depends on if it's occurring at a critical phenological stage for a particular crop. Those are different times of the year, different regions, different seasons, corn versus beans versus wheat versus specialty crops. That's something to keep in mind too, how these are pretty tailored. Context does matter. Okay. The last question, difference between impacts. Let's see, let me get to the last question here. Indicators, the ones that popped up, no big surprises there. I won't belabor the point. Health was one, though, that we did speak a little bit to. So that was a unique one that I hadn't heard mentioned here. We had Jesse Bell in our group, so we tapped into him talking about flash or traditional droughts and the impacts on health. Heat waves is very important there. Algae blooms, things of that nature that may affect recreation and other things of that nature. So water quality, not just water quantity, if I had to summarize that all up. And soil moisture and ET, of course, being some of the other primary ones. And with that, I'll turn it back over to you. Thanks.
Great, thank you very much, Mark. Okay, I'll invite Joel to join me as a co-moderator. We now have about 15 minutes left for a more extended discussion on this question about key characteristics of flash drought and also how we might want to put guardrails on definitions. We do have the chat box if anyone who wants to add in there, or again, if you want to put hand down, if you have something more to say, that would be great. But just to start off, having sort of immersed yourself in the literature on this, and then listening to the breakout reports, do you see us bringing those guardrails together a little bit closer in terms of our conception of flash drought, or is it something that I work on a little bit more?
So yeah, I definitely think that coming in a little closer. Every group mentioned that rapid intensification was a key characteristic, although it wasn't the key characteristic. And I think that that's where we need to remember, that's something we need to remember as a group and as a body of researchers going forward, that there can be many ways to characterize flash drought, but in every one of the groups today, this rapid onset came up. Also interesting that a short duration drought didn't come up that often, although it showed up in the literature search, not as often as a rapid intensification drought, but it came up quite a lot. So I think in our large group discussion, I think I'd be a little interested to hear some people's perspective if there are different perspectives that haven't been shared yet. I also, I don't remember who mentioned it, but in somebody's report out, they mentioned that even if we are focusing on the rapid intensification characteristic of a flash drought, that doesn't mean that short duration droughts are not also important to study and understand, especially the physical characteristics of those, why they happen, and the seasonality of those and the impacts that can come from those. So I thought that that was an interesting aspect that came up. I'd be really interested to hear if there were some other perspectives.
Right, so just to open it up to all of you, 100+ people, if any of you want to reflect on what you've heard from these breakouts. Again, felt like we had quite a amount of sharing, but still some questions on how we hone this approach to a definition or definitions. It did seem like there was a lot of clarity about the importance of regional and sectoral based differences, which I think we had some question about going into this.
Yeah, I guess this is Art Digatano. One question that comes to mind is, yes, there's lots of different definitions and things like that floating around. So it's almost like in some ways I got out of the breakout in today's sort of like herding cats. What I really haven't heard from, and maybe it was just because of the makeup of our breakout group, is really from a stakeholder. So I'm going to pick on Vicky from Massachusetts because I know she's out there and we work close together. I guess what I'm wondering from a stakeholder's perspective, what is kind of important? Why would you want to, we kind of have a feeling that this flash drought is rapid onset and things like that. But what about something like that would make somebody say in the Massachusetts Drought Task Force really take note? So kind of, I've heard a lot of the scientist perspective, but I guess I'm trying to get at maybe what a stakeholder's perspective is and how they would find it practically useful.
Looks like Vicky put a comment in the chat box.
This is Vicky, and I just commented exactly on this. Why are we sitting here defining this? Because we define it however we want. So what's our purpose? What's the utility? So from my perspective, I want to know when I need to act more quickly than I'm used to. So we used to do monthly monitoring, and Art and his group are now helping us develop some a drought portal that's going to automatically calculate our indices and allow us to check in weekly without much staff time, so we can really focus on keeping track of what's happening as opposed to crunching data. And so I would want to get an alert about a rapid change, and whether that's at the onset or in the midst of a drought, rapid change for worsening, I guess, a rapid change for worsening, so that we can alert our stakeholders and get our resources moving, whether it's at the start or during the drought, because it's elevating. But that's where I think talking about nuanced things like the wheat growing community, that's way too far in the weeds, and also then requires very extensive, complex indices specific to that. for my use, something more generic where I know water availability is decreasing rapidly. At that level, that would be most useful for me. And we've been working with Art trying to get an early drought indicator or an early onset indicator, and because the last 2 droughts have been challenging with respect to that. We were looking at all the indices mentioned today, and it's a little bit of grappling. So I took note of what people commented about Eddy, which was a top contender. So we'll see how it goes from there. But for what it's worth, that's my 2 cents.
Thanks, Vicki.
And I swear I didn't read her chat before I spoke, so.
Your mind melded up there in the Northeast. Okay. No, that was very well put. And I know we're getting some more comments in the chat. I don't know if anyone who's writing the chat would like to speak up. Dennis, it looks like you've got some thoughts there, or others.
Yeah, I was typing and Vicki was indicating something similar to what I was typing, is that the definition of what is occurring and what is coming up is not as important as what the end user needs to know about. What actions do they need to take? Are we bad and likely to get worse? Then there's an intermediary that needs to indicate that to the end user, and then they take appropriate actions. And what form that needs to take and what the end user actions need to take really vary widely across the country and based on the stakeholder need. So we can't, as scientists, we can't do that, but as boundary entities, we should be ready to do that constantly and be reaching out in ways of doing that. There's a number of examples. The Midwest drought, the Central US drought webinars have been going on forever. Art's doing something. A lot of state climatologists do these similar kinds of thing. Entities who work in that boundary area that have that context and ability to communicate that are invaluable.
Great.
This is Danelle, if I can respond to Dennis's comment quickly. Dennis, you just made me think about the difference between forecasting a flash drought versus classifying a flash drought in hindsight. And why I thought of that was in agriculture, it's so common that farmers and ranchers on the ground already see these things happening long before we as scientists are aware of it. And so if we're doing real time from an agricultural perspective, I'm not sure they need us to tell them that things are changing rapidly. If we're forecasting, that's a different, right? Then we are kind of giving them an early warning that something might be coming. But even real time could be helpful for policymakers or people that are administering programs who need evidence that something unusual happened that resulted in these agricultural losses.
All right. Great, thank you. That's why we wanted to bring practitioners. Sorry, let me just finish. That's why we wanted to bring practitioners here into this conversation with researchers, just so we can have this sort of cross-fertilization and all focus together on sort of the same goal, which is making a difference in the world with the work that we're doing. I'm going to let Jason Otkin go next. He's had his hand up. He's been a little while. Go ahead, Jason.
Yeah, I was just going to follow up on the very first bullet point that you made, and disagree with the article that you chose to use, where I don't think it's necessarily a key characteristic. It's actually the key characteristic, because that some of the other characteristics that have been discussed are really just kind of an impact, whether it be decrease in soil moisture or vegetation impacts. But the key characteristic here is still the rapid intensification. And that then feeds into what Vicki and others have been saying, to where it's important to know how quickly things are developing, how quickly things are worsening, because that then gives you more time to make mitigation, to do different things to try to lessen the impacts. Because I think one of the things that hasn't been brought up today is the role of land surface feedbacks and memory. Where these flash droughts, once they get going, they can kind of build on themselves. To where if you're in a flash drought today, you're probably going to keep going downhill. for a couple of weeks because the atmospheric patterns are locked into place. The land surface starting to feed back on itself. So there is a predictability there anyway, just based on the antecedent conditions.
Great, thank you for that. Okay, Mark Svoboda.
Yeah, thank you, Marina. This issue of translation, I think that really it harkens me back to when we first started the Drought Monitor. This group here, speaking of sort of our at least let me speak for the non-practitioners, right? The scientists and people studying this that are more intimately familiar with flash drought. People wanted one map with a single number on it, a decision maker, a policy maker, the media. They didn't want to dig into 25 indicators. So I think that was one of our motivations to come up with a simple, historically based on percentiles, was to combine not apples and apples, but apples and oranges, which we have a lot of, right? This is a big fruit cocktail we're talking about here with all of these indicators and indices that have been discussed. I would disagree with the notion that the Drought Monitor can't more reactively respond to flash drought. Indeed, it has improved dramatically from the 2012 drought, which wasn't forecasted either, as we know, to the 2017, which the lag was just on the matter of a week or two, not 2 or 3 months like we saw in 2012. And why was that? That's because we're using the new tools you're talking about here, EDDI, ESI, Quick Dry, Veg Dry, the new suite of LDAS, Ensemble, soil moisture models, things of that nature. That has helped our response time. In addition, most of the states have direct input into providing impacts and feedback to that process. So there's a built-in validation to it that a lot of products just don't have. And secondly, I think that misnomer that, yeah, the Drought Monitor itself is only 20 years old. Most of the inputs going into it go back 60 to 80 to 90 years. We're using NCEI data, we're using the Regional Climate Center ACES database and others that the Climate Division data going back to 1895. So yeah, the Drought Monitor, we can't go back and make it for the 1930s, but we can start to look at various combinations of indicators using blends like in a machine learning approach to start looking at things like flash drought. And we are doing that, and NIDIS has been funding that sort of research lately. A little too early to give the results here in this particular workshop. So I'm not totally in the light that the USDM can't be used better as an early warning system. It's just that it's hard to overcome human nature, believe in some of these new breed tools, and some of those new tools don't have many years of data. Some of the purely satellite-based platforms only go back a decade, 15 years. So that's the same argument for that. So just wanted to get that out there on the table.
Great, thank you very much. Okay, we've got a couple more hands up. Multivel, I think you're up next.
Okay, besides repeating what I already said, a couple of things I'm walking away with is that what I hear from the work groups and from here is that people want early warnings or indications of developing conditions. I think it is that's a key thing I'm walking away with. And yes, the US Drought Monitor is not perfect, and it has limited data. But we at CPC are working on a rough equivalent with the root mean square difference error of close to very 0.18 or something less of reproducing the US Drought Monitor in a objective way, and we are going back to 1979. So there will be a lot more the US Drought Monitor equivalents over a longer period, and we are hoping that soon that there will be condition, because as somebody said, the US Drought Monitor is a subjective blend, and there is a lot more new data coming in. And a human person comprehensively cannot integrate all these things, and there is a time lag. So we are in the process of producing something daily, of indicating potential areas of dryness development and possible drought development on a daily basis. So these are all going to be experimental, and we will produce it online, that for all kinds of users, including the US Drought Monitor authors, to fall back on and So there are efforts going on, hopefully alleviate some of the problems discussed here.
Great. Okay, we've got one more question from Ronnie Leeper.
Hey, can everyone hear me?
Yep.
Yeah.
Awesome. I just wanted to bring up something that I guess hasn't been discussed in the group forum yet, but looking at, I guess, drought having some sort of impact for it to be a flash drought in terms of the definition. And I'm not completely against there being an impact in order for it to be a flash drought, but if we don't have a good understanding of what the potential impacts are of flash droughts or droughts in general on people in society. So think back to what Mark Savoto just said about Jesse Bell, where we're still learning a lot about how drought might impact people in society. If for instance, we don't have an impact, and so we don't so it meets the rapid intensification, but we don't see an impact because it didn't impact vegetation. Maybe it occurred in winter, but later we find there is a human impact, a human health impact. Do we then reclassify that as a flash drought event because it met the second part of the criteria? So I just wanted to throw that out there as a discussion. I don't have a great answer for that, but I just wanted to think a little bit about, like, if we require an impact, we may not understand what the impacts are in the future as we learn about how drought manifests in terms of human health. So if you think of Lyme disease, or if you think of valley fever, those are other things that, you know, are human health, where drought can impact those type of events. So that's just kind of I just wanted to throw that out there and see what other people thought.
Great. Yep, that's a good point. Okay,
Ronnie,
well,
as you were talking, there were a few comments that came into the chat box about what you were saying. If you wanted to, I don't know if you're reading the chat box as you were talking. That might be helpful for you. Sorry,
yeah.
Marina, you were about to say something.
I was going to say we are close to our time, and just understanding people are busy, and we do have a couple more days. Not that this conversation is over, but I think for now we're going to wrap it up for now. We will, as I said, keep the chat box and extract some of the important discussion flow points through that. So we're going to bring that forward, as well as, of course, the breakout notes, and try to document a little bit of where we've come together on this. And I should point out that this is not the end of this conversation at the workshop. We're actually going to circle back to this question about characteristics and definitions on the third day, once we've gone through the next couple days process. So that will do it for today's program. We're going to be signing back on tomorrow at 11 a.m. Eastern, and it'll be a little bit of a shorter day. We're going to again get into the mindset of those stakeholders and practitioners that we all care so much about and have heard a little bit from, so we can really think about what are their needs, you know, honoring this question of, do we need to know impacts to call it a flash drought that was just raised, but still in the context of flash drought and the effects in the world, what are the needs of the user community, and how can we do a better job of getting tools and research to meet those needs? We'll start there tomorrow. Anything else, Joel, end with?
Yeah, so Molly just put into the chat box, asking if we can leave the chat box open for just a little bit to sort of finish up some of the conversations that are currently flowing there. And I think that's a great idea. We'll probably leave it open for maybe another, what do you think, like 15 minutes after
Sure.
the meeting ends, if people want to continue those conversations now, and then we can pick up again, as you said, in a couple of days. We'll be meeting tomorrow, but this particular discussion will come up on Thursday.
That's right, yes.
Quick question. There was an email given at the beginning that was for logistical or technical questions. Would you be able to repost that or put it in the chat?
Oh, yes.
Thank you.
I can do that right now. Actually, Tammy, can you go ahead and do that, since you know your email and phone number right off the top of your head? Maybe Campbell. But otherwise, yeah, we'll turn off our cameras, keep the program going, and again, welcome to keep chatting along, and otherwise we'll see you tomorrow morning, or whatever. Yeah, 11 o'clock Eastern. Thanks again, everybody.
Thank you.